In the 7th century, the Pallava dynasty dominated the northern Tamil region. To mark their territory, they turned to the most durable medium available, the massive granite outcrops scattered across Mahabalipuram. Their early engineers relied on a subtractive method. Instead of building a structure from the ground up, they would locate a pre-existing boulder, take a chisel, and carve away every piece of rock that wasn't a temple. You can see the rawest form of this technique at Mandegapattu. Here, Pallava masons bored directly into a natural cliff face, hollowing out the interior to leave behind these heavy rectangular pillars. They eventually evolved this method to create freestanding monuments. By isolating a massive boulder and carving it from the outside in, they could reveal a fully formed three-dimensional temple known as a ratha. At the Pancharathas complex, the scale of this effort is clear. Every temple and sculpture in this frame, including that massive lion, was carved downward from a single continuous footprint of bedrock. These monoliths proved the Pallavas were masters of stone. But as their ambitions grew, the subtractive method reached its physical limit. The primary constraint was geographic. In a subtractive system, you can only build a temple where a giant rock already exists. If a king wanted a monument in a city center or on a harbor, he was out of luck. Then there was the structural risk. Because the temple is one single piece of stone, there is no room for error. If a mason strikes a chisel too hard and causes a catastrophic crack, the entire multi-year project is ruined. King Narasimhavarman II, also known as Rajasimha, sought to move beyond these boulders. He wanted to build monuments whose size and location were determined by his vision, not by the placement of random rocks. This required a total change in engineering logic, a way to stack individual stones to create massive, freestanding buildings that could survive for centuries without the use of binding mortar or cement. The solution was the additive process. Instead of carving away at one rock, engineers would quarry separate granite blocks, transport them to a site, and stack them one on top of the other. Subtractive carving relies on removal, but the additive method lets a structure grow, giving architects freedom to determine the building's dimensions from scratch. To hold it together without cement, they used dry masonry. Stones were cut with precise joints, interlocking like heavy granite puzzle pieces. This system relies on gravity. The sheer weight of the stones presses down on the interlocking joints, creating enough friction to prevent the structure from shifting or collapsing. This stocking technique allowed the Pallavas to move away from cliff faces and into the open, creating the first structural stone temples in southern India. The first major demonstration of this stacking technology was the Kailasanathar Temple, built inland at the Pallava capital of Kanchipuram. Kailasanatha was built entirely of separate stone blocks. Its most striking feature is the vimana, a towering, tiered pyramid that rises high above the sanctum, a height that was impossible to achieve through mere rock carving. The engineers were strategic with their materials. They used a heavy granite base to support the structure's weight, but the upper tiers were made of sandstone, which allowed artists to carve the incredibly intricate details covering the walls. Stacking blocks also allowed for complex planning. Architects could now include a large assembly hall, or mandapa, and a perimeter wall lined with dozens of small, repetitive shrines dedicated to the various forms of Shiva. By combining these elements, the tiered tower, the pillared hall, and the enclosed courtyard, Kailasanatha established the structural blueprint that would be followed by virtually every major South Indian temple for the next 1,000 years. Having proven the technology inland, Rajasimha took the additive method to the coast of Mahabalipuram for a final engineering challenge. The Shore Temple was built mere meters from the Bay of Bengal. Its placement was tactical. The towers were meant to act as a landmark for seafarers navigating the busy maritime trade routes between India and the East. Because of the environment, the builders abandoned sandstone. They constructed the entire temple from ultra-hard, locally quarried granite blocks, specifically to withstand centuries of salt-laden winds and crashing waves. The flexibility of stackable blocks allowed for a complex floor plan containing 3 shrines, 2 for Shiva and 1 for Vishnu. Although the granite surfaces have been softened by 1,300 years of erosion, the underlying dry masonry remains perfectly intact. The temple's survival through multiple tsunamis and centuries of coastal weathering validated Rajasimha's engineering. Stone blocks, correctly stacked and interlocked, could outlast the very mountains they were cut from. In medieval India, a towering stone temple was more than a house of worship. It was an expensive, permanent marker of imperial legitimacy. Building a mountain of stone signaled that a dynasty was wealthy, stable, and favored by gods. This made the Rajasimha Style a target for rival kings. 30 years after Kailasanathar was built, King Vikramaditya invaded and conquered the Pallava capital. But instead of destroying the temple, he was so impressed by its structural sophistication that he spared the city and funded the temple's maintenance. He even brought Pallava architects back to his own kingdom to copy the stacked stone design for his own royal monuments. Because of this widespread respect, the Pallavas' engineering survived their military defeats, becoming the international standard for how a South Indian king was expected to build. Succeeding dynasties, particularly the Cholas, took the Pallavas' additive blueprint and pushed it to massive proportions, creating some of the largest monuments in the ancient world. These later structures reached incredible heights, with towers that dwarfed anything that had come before. But these massive weights were only possible because of the foundation Rajasimha laid. He proved that you didn't need a mountain to build a temple, you just needed to know how to stack the stones. The Shore Temple and Kailasanathar were the functional prototypes for an entire civilization's architecture, providing the structural logic that would define the South Indian skyline for over a millennium.